So here's two tan problems that I'd like to try. These are a little bit different from the ones prior. There's no phase shift, but the periods will be different. So why don't you find the amp and the period. We'll call it A and B also for each of these. So like we said with tan, because of the graph of tan, there is no true amplitude. We can write NA. My period is pi over B. So in this case, it's going to be pi over 1/2, which will be 2 pi. And my A and B values, well, this is my A value and this is my B value. So A is -5 and B is 1/2. So anytime I'm graphing, I like to graph the basic curve. And we know a tan curve. Oh, this is a negative tan. I already messed up. We'll make this a negative tan curve. So it's got to reflect over the x-axis. All right, so it's actually going to go down like that. Right? And because this is a negative tan function, it would look like that. My period is 2 pi. So the period for tan actually goes here, right, before it starts repeating. Right, one cycle is completed from here to here. It goes down, right, and then that same image is repeated. So my period is always written here. And then we like to look, half of the period will be where this isotope is. Half of the period is where the isotope will be. So 1/2 times 2 pi is equal to pi. So this will be pi. And halfway from 0 to the isotope is where we'll find our convenient point. So we could say, since that's half, let's call it 1/4 times the period will give us this convenient point. That would be my x value. So in this case, 1/4 of the period, so that's going to be my x value, and then I'm going to have a y value. 1/4 of the period could be calculated as 1/4 times 2 pi, which will be half pi, which we can see this looks like it's half pi, right? It's halfway between 0 and pi. And then what's my y value going to be? Well, if I plug it in to this problem, if I have y equals -5 tan 1/2 times x, and x is pi over 2, well, that'll give me -5 tan 1/2 pi over 2 is pi over 4. And we discussed earlier, pi over 4 is always equal to 1. So this is -5 times 1. So this will be -5. And what we'll find is this will always be the case. So this convenient point will always be 1/4 of the period for the x coordinate, and the y coordinate will always be the a value. Oh, I wanted to write a value. A value. A value. So in this next example, so we have that point. So we have 1/2 pi -5, right? So if I wanted to find these other points, this would be +5. We're going to have a point here. We're going to have a point here. We're going to have a point here, right? And we're moving in increments of 1/2 pi. So this is 1/2 pi, right? 2/2 pi. This is going to be 3/2 pi, right? So this point is 3/2 pi 5. 4/2 pi 0. 5/2 pi -5. 6/2 pi. This is going to be 7/2 pi. So that point would be 7/2 pi 5. So you'd be able to find all of them by counting by 1/2 pies. And the calculation, like I said, to find that convenient point is always 1/4 the period, comma, the a value. So in this example, in this next example, my amplitude in tan doesn't exist, but my a value is 7. My period is pi over b, so it's going to be pi over 2. And my b is 1/2. So actually, let's put our convenient point in, and our amplitude, and our asymptote. Your first asymptote is going to be 1/2 times the period. And your first, that convenient point is going to be 1/4 the period, comma, a. So in this example, 1/2 the period, 1/2 times pi over 2, this is going to be pi over 4. And my convenient point is going to be 1/4 times pi over 2, 1/4 of the period, which is pi over 8, comma, my a value in this case is 7. So when I go to graph this, I have a regular tan graph. It's not reflecting or anything like that. It just looks like that. My period is always written here. We said the period is pi over 2. This asymptote is half of that, so it's pi over 4. And our convenient point is pi over 8, 7. Right? And then if you wanted to find additional points, you would be able to do that relatively easy. You're counting by 1/8. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. All right, so we could find these points by counting by 1/8 pi. And down here, if this is +7, this is -7. So I could find additional points. It's going to get sloppy with me writing in the points. 1/8, 2/8, 3/8, 4/8. So this is 3/8. pi negative 7. This is 5/8 pi positive 7. And this is 7/8 pi negative 7. And this is 8/8 pi, which is just pi and 0. Right? So we'd be able to find all the points